I cannot leave.
But you are my sister's husband.
But she dirty skunk.
Alicia is not dirty skunk. She is my sister.
Did you just call me a dirty skunk?
Oh no!
Get out of my house! Get away from my sister!
Oh!
Get away!
I tried to defend you, Alicia.
You know what? You've been cheating on him the whole time!
Oh my God, I'm sorry. Ah! 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 Oh God! Oh!
My teacher, no! Ho, 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 ho!
Santa's belly is spherical in shape. On Christmas, his belly size increases at a rate of 3 centimeters per second. At what rate is the volume changing when the radius of Santa's belly is 10 centimeters? After you solve this problem, you should get an answer of 3,770 centimeters cubed over seconds. Then you figure out that Santa wants to go for a dip in his hot tub. As Santa's belly grows, he must constantly be altering the size of his hot tub. If the volume of his hot tub increases constantly with Santa's belly at a rate of 3,770 centimeters cubed per second, what is the height of this 500 centimeter wide cylindrical hot tube? Now you find that the height is approximately 5,000 centimeters, which is virtually impossible for Santa to fit his belly in completely, so he only gets the tips of his feet wet. So Santa is sad Santa. Poor Santa. Okay, you can stop recording. Scoot signed up to take part in an experimental new sport drink test. He was forced to drive downtown and drink out of a cylindrical office water jug every day for 6 years. The jug is cylindrical in shape with a radius of 20 inches and a height of 42 inches. Scoot notices every day that the height of the water was 18 inches, but has been dropping at a rate of 2 inches per minute. How fast is the water disappearing? If you calculate this correctly, you will discover that the water is decreasing at a rate of negative 800 pi inches cubed per minute. After this, Scoot collects the juice in his duct tape funnel to carry with him all day. The funnel has a radius of 4 inches and a height of 6 inches. How fast is the height of the water cup duct tape thing in the cup increasing when it is 3 inches? If you calculate this correctly, you will receive 25 inches per minute. That is a lot of water. I can't. I can't.
I don't know what you're doing right now.
You're not even getting his throat. Right? There you go.
I can still breathe!
Make it look real.
I'm just trying to breathe.
There. Now he's dead.
Mind the background.
Yeah.
Wait, Scott, stand further back.
He needed to stun him with laser before he stole them. The wheel had a radius of 30 centimeters, revolves at a rate of 10 revolutions per second. He keeps his laser on point P and on the rim of the wheel. For the first part of this problem, Scott would like you to find dx over dt as a function of theta. So, if you calculate that correctly, you will receive negative 600 pi sine theta. Next, Scott would like you to find dx divided by dt when theta equals 30 degrees and theta equals 60 degrees. For 30 degrees, you will receive negative 300 pi centimeters per second. Second, it's a part of a minute. And then for the theta equals 60 degrees, you will receive negative 300 times the root of 3, the cube root of 3, no, the square root of 3 times pi centimeters per second. And that is your answer, and you have discovered the murder mystery that is Scott's death. He was murdered by the scientist Alectoria. Alectoria. No, Alyssa. No, it's Elisa. Elisa's murderer.
Well done.
Elisa's murderer is always Victoria name. Once upon a time, there was a man scout named Roberto. Roberto was such an avid man scout that one day he noticed his fellow man scout, Robert, with his medal of treetop screwing. Roberto was so jealous and knew that he had to beat Robert. He then got a 25-foot tall letter which he stole from Elisa and Victoria's funhouse. Unluckily for him, though, he did not realize that the bottom of the ladder was magic and always slid away from tree at the rate of 2 feet per second. As Roberto would climb the ladder, the top of the tree would slide down. How fast was the top of the ladder moving down the tree when Roberto fell off when his base was 15 feet away from the bottom of the tree? That is the question. If you calculate all this correctly, you will receive that it is slipping at the rate of negative 712 feet per second. Congratulations, Roberto. Robert and Roberto Scott.
The mirror's image, it tells me it's home time, but I'm not finished.